we're going to take a look at a new set of formulas, which are going to be the power reducing formulas. These are actually really easy to prove. Okay, so let's go ahead and prove each of these really quickly. So sine square is going to be 1 minus cos 2x over 2, cos square 1 plus 2x over 2, tan square 1 minus cos 2x divided by 1 plus cos 2x. To verify these, let's recall that the cosine of 2x could be written as 1 minus 2 sine square of x. Okay, so remember we proved that in the last set of videos. If I subtract 1, so I could say this is the same thing as cos 2x minus 1 equals negative 2 sine square x. And then if I divide both sides by negative 2, that would flip the signs around and we would end up with 1 minus cos 2x divided by 2, which is equal to sine square of x, which is precisely what we have. Okay. Not surprisingly, I can do the exact same thing to prove the cos square function. So remember, cos of 2x is also equal to 2 cos square of x minus 1. I can add 1 to both sides, so I get cos of 2x plus 1 equals 2 cos square of x, and then I can divide by 2, and then I could just flip the two terms in the numerator around, and so I could get 1 plus cos 2x divided by 2 equals our cos square of x, right? And so the last one we have to prove is the tangent, okay? And tan square. Now remember, we can write tan square as sine square over cos square. So tan square of x is the same thing as sine square x over cos square x. And we know sine square can be written as this. So 1 minus cos 2x over 2. And we know cos square can be written as 1 plus cos 2x divided by 2. Right? 2's would cancel out. We'd multiply by the reciprocal. And that gives us 1 minus cos 2x divided by 1 plus cos of 2x. Okay, so easy enough, right? That's our tangent square formula. So that's how we can prove all of these. None of them are particularly difficult to prove, okay? Now, let's see these in action, okay? This is a pretty common sort of thing that we'd have to do in a course like Calculus 2 to be able to evaluate some higher level sorts of things. So we want to use the power reducing formulas to rewrite an expression as an equivalent expression that doesn't contain powers of trigonometric functions greater than 1. So we have this 8 sine to the fourth of x, okay? It's really difficult to work with sine to the fourth of x. So let's rewrite this, 8 sine to the fourth of x. Let's rewrite it as 8 sine square x squared. And we certainly know that this is the same as 8, and we just proved that sine square of x is 1 minus cos of 2x divided by 2, okay? So that's the square, but we do have to square that, right? And if we square it, that could be written as 8 times the quantity of 1 minus cos 2x quantity square divided by 4. All right. And the reason I did that first before I squared anything out was because I wanted to simplify this. Now the 8 and the 4 are going to simplify to a 2, right? And so really what I have is 2 times this expression. So 2 times the quantity of 1 minus cos 2x squared which is the same as 2 times the or 2 times 1 minus cos 2x times 1 minus cos 2x. All right. And so now what I can do is I can FOIL that out. Okay. And now we're going to have powers that aren't going to be any greater than 1. Okay. So when we FOIL it, we have the 2 on the outside. 1 times 1, 1. 1 times negative cos 2x is negative cos 2x. And then we're going to have another minus cos 2x. And then, unfortunately, this is going to become a positive cos square of 2x, okay? But nothing to worry about, okay? Because we could use the power reducing formula again on this, okay? And so we know that cos square of 2x is going to become by looking at our power reducing formula. Okay, so let's go all the way back up here. And we have cos square of 2x is going to be, or cos of square of x is 1 plus cos 2x over 2. So we just have to double this interior angle. So this is going to be 1 cos of 4x over 2. Okay. These two are going to combine. So we get a minus 2 cos 2x. And then finally, we have the 1 out front. We still have everything multiplied by 2. All right. Now let's distribute the 2 to everything. Okay. When we distribute the 2 here, it's going to cancel that out. So we end up with 2 minus 4 cos of 2x plus 1 plus cos 4x. Right? And then finally, the last thing we can do is we can combine this 1 and 2. And so we end up with 3 minus 4 cos of 2x plus cos of 4x. All right. Now notice that these two terms are not like, okay, because one has a 2 and one has a 4x. Okay. And that's as simple as we can make that. Another example of this, we have 24 sine square cos square of x. And again, the goal is for us to be able to write this as an expression that doesn't have any powers greater than 1. Okay. Just like up here, this is the first power and this is the first power. All right. So let's rewrite this now. 24. We know that sine square can be written as 1 minus cos of 2x over 2. And then we know that cos square can be written as 1 plus cos 2x over 2. Simplifying this, we know that 24 divided by 2 is going to be a 6. Okay, so basically we have 24 divided by 4 because of the 2 and the 2. So this really just becomes 6, 1 minus cos 2x times 1 plus cos 2x. Now we're going to FOIL. Okay, so 1 times 1, we get 6, 1. 1 times positive cos 2x is going to be a cos 2x. Then we have the negative cos 2x. And then unfortunately, we're going to get a negative cos square of 2x. Okay, and that's okay because we already know how to take care of that from the previous video, or from the previous problem, excuse me. We know that cos square can be written as 1 plus cos of 2x, but we have to double the interior angle. Okay, so this 2x becomes now 4x. Okay, and again, all I'm doing is I'm just using this formula right here. Okay, so we're just going from here to here, except we have a 2x, and so we have to double it right here. Okay, so just like we did in the previous. All right, so now we have 6 times the quantity of 1 minus 1 plus cos 4x divided by 2. I'm going to distribute the 6 to both of these. Now, this one, the first term becomes 6, but then we get 3 because the 2 and the 6 are going to simplify to a 3 when we distribute 1 plus cos 4x. And then finally, we can distribute the negative 3. So 6 minus 3 minus 3 cos of 4x, or 3 minus 3 cos of 4x. Or if you want to be really fancy, we can factor the 3 out and 1 minus cos of 4x times 3. Okay. Either of these answers is perfectly fine. Okay. And again, what we've done is we've written this with no power greater than 1 for our trigonometry. Okay. All right. So that's our power reducing formulas. Okay. Not too difficult. Now, in the last video, what we're going to do, or the last videos, we're going to go ahead and take a look at our half angle formulas. Okay. And they're probably going to be a little bit more complex than the other ones we've seen, but they shouldn't be too bad for us.